So this is our last unit before our test next week. And a lot of it's just review. We're just putting a lot of the things that we've learned together. Okay? So we know the distance formula, and we know that we can use it to prove theorems about quadrilaterals. Let's see if we can fill in some of these blanks. A quadrilateral is a parallelogram if both pairs of opposite sides are blank to each other. I think I heard it. Parallel. So if both pairs of opposite sides are parallel to each other, we have a parallelogram. This next one, you might have to look at your chart from last Monday that has all the properties listed on it. So a parallelogram is a blank if its diagonals are congruent to each other. I'm not going to give you the answer. I want you to look. So look back at the chart from like a week and a half ago. A parallelogram is a blank if its diagonals are congruent to each other. What can the figure be if its diagonals are congruent? Okay, we should be looking either at our chart or sitting quietly. What figure is a parallelogram if its diagonals are congruent to each other? A square is one of them. It's crossed off on your chart. Is there anything else? A rectangle. Is there anything else crossed off on your chart? An isosceles trapezoid. Is that going to be a parallelogram? Is an isosceles trapezoid a parallelogram? No, because both pairs of opposite sides are not parallel. So the definition of a parallelogram is both pairs of opposite sides have to be parallel. So the diagonals may be congruent to each other, but it's not a parallelogram, so it doesn't fit this right now. Okay? Sides and diagonals can be proven blank by showing that the distances between their endpoints are equal. What word do you think goes in there? Congruent. Yep. And then we should all know the distance formula. What does the distance formula help us find? The distance from one point to the other. We can also call it the length of something. Okay? So let's start by plotting those 4 points. Okay? So everyone take a second and plot those 4 points on your graph. So again, this is going to be review. We're just going to kind of pull everything we've talked about over the last week and a half together. So for part A, we want to prove that EFGH is a parallelogram. How would I prove EFGH is a parallelogram? What do I need to show? Both pairs of opposite sides are parallel. So I need to show that FG is parallel, oh, that's an E, to EH, and EF is parallel to GH. Everyone okay with that? Okay, so we're showing both pairs of opposite sides are parallel. So now let's take a second, everyone take a second, and find the slope of each of those sides. So you can use the slope formula, or you can count rise over run. Can someone tell me what the slope of FG is? What is the slope of FG? Negative 1 over 3. So if you were to count, you went up 2, backwards 6, right? which then reduces to negative 1 over 3. Are we all okay with that?
Yeah.
Okay. Someone else, what is the slope of EH? What is the slope of EH? Negative what? Negative 2 over 6, which is the same as negative 1 over 3, right? Are these two sides parallel? Yes, they have the same slope. Okay, so far so good. Who found the slope of EF and can give us the slope of EF? 3 over 1? Okay, so you went up 3 over 1. And what about GH? So if I'm going from G to H, how many do I go down?
3.
I go down 3, and I go backwards 1. So that's a negative 3 over negative 1, which is the same as 3 over 1. Are these two sides parallel? Yes. So we can say our figure is a parallelogram. Our figure, the figure, however you want to write it. So the figure is a parallelogram. Now, if we want to prove it's a rectangle, there's two pieces of information that you had on your quiz that we've talked about before to show something's a rectangle. What's the first thing you need to show? Opposite sides are parallel. You just did that, right? So I don't need you to do it again. You already showed me that it's a parallelogram, so we're good. What's the second piece of information we need? 4 right angles, which means the consecutive sides are perpendicular. Okay, so we need to show that FG is perpendicular to GH. GH is perpendicular to HE. HE is perpendicular to EF, and EF is perpendicular to FG. You need to show that all of those sides create right angles. You've already found the slope, right? We just did all the slopes. So let's just fill them in. FG is negative 1/3. GH is 3 over 1. HE is negative 1/3. And EF is 3 over 1. Is FG perpendicular to GH? Yes, because they have opposite reciprocal slopes. What about these two sides? Yes? Yes? And yes, all the way down. Okay, so we know it's a parallelogram. We know all of the angles are right angles, so we can say the figure is a rectangle. Right? Everything we've already been doing. It just broke it up into steps. Still good? Yeah? Okay. How would I show that the figure is a rhombus? What's important information that I need to show it's a rhombus? What do you think is going to be the important information to show it's a rhombus? So both pairs of opposite sides are parallel, yeah, because it's a parallelogram. Did I already show that? Okay. What else is going to be super important for a rhombus? Something about the sides. Yeah. All sides are congruent. I need to show that all sides are equal. How do I show that the sides are equal? What can I use? If I'm looking for the length of something, what am I going to use? The distance formula. Okay, so here's what I need to show. I need to show that FG is equal to GH, which is equal to HE, which is equal to EF. I need to show all four sides equal each other. Now, if you look at that figure, what would your assumption be? Are all four sides equal? No, probably not. But you can't just say that. We actually have to show it. So let's start with a side. Let's start with FG. And let's do GH. We have to at least compare two sides. And let's see if their distances are the same. If they are, we're going to keep going. If they're not, we can stop. So I want you to take a second and use the distance formula to find FG and GH. Okay, let's make sure we're on the right track. So if I want FG, I'm going to look at the 2 points for FG, label them x1, y1, x2, y2, and plug it in. So if I look at these two, it would be 3 minus that negative 3, which would be a positive 3, squared, plus 0 minus 2 squared. 3 plus 3 is 6. 6 squared, 36. 0 minus negative 2 is a negative 2. Negative 2 squared is 4. So this gives me the square root of 40. Can I simplify that at all?
Yes.
If I do the factor tree, I get 4 and 10, 2 and 2, 2 and 5. You are looking for pairs. So this pair of 2's comes out, and what's left over? The 5 and the 2. So to put them back together, we're going to multiply, giving me 2 square root of 10. Are we okay on that distance? Okay, let's find the distance of G and H. So same thing. 2 minus 3 squared plus negative 3 minus 0 squared. 2 minus 3 is negative 1. Negative 1 squared is 1. Negative 3 minus 0 is negative 3. Negative 3 squared is 9. That gives me the square root of 10. Can I simplify that at all? No, because it's just 2 times 5. There's no pairs. Are these two distances the exact same? No. We can stop. Because we've shown that two sides aren't the same, it doesn't matter what the rest of them are. So this is not a rhombus. We don't have to show anything else because we showed that two sides are not congruent. Okay, so let's talk about what we would have to do to show it's a square. What are some things? Where would we start? What's the first thing we would do to show it's a square? Both pairs of opposite sides need to be parallel. We already showed that, right? What else does a square have? Right angles, right? We showed that all the angles are right angles. So we've showed two of our three steps. What's the third thing a square has? All congruent sides. What did we just show? The sides are not congruent. All sides are not congruent, right? So is this going to be a square? No. Here's how I would write the sentence. The figure is not a square because all sides are not congruent. Even though the opposite sides are parallel and angles are 90 degrees. So you don't have to do all the work again if you've already shown it in the steps above. Okay, it's in this order for a reason. It kind of breaks it all down for you.